Hello, I'm Bill Snyder. We're coming back to do a final walkthrough of this M&P course. And today we're going to talk about functional overview, troubleshooting, and then a little bit of cleaning of the indoor unit, how to do some cleaning. So we're going to try a video. Hopefully that works for you. Right now, we're going to start with the functional overview of the equipment, and we're going to talk a little bit about wiring and a few other things. So let's get started here. We're going to talk about some wiring and some piping and some different things, but first of all, let's start off with earlier in the day or earlier sessions, I talked about S1, S2, and S3. S1 and S2 are your line voltage between your indoor and outdoor unit on S1 and S2. So across those, you should read 208, 230 volts right in there. And between S2 and 3, you're going to get a DC volt. It's kind of an artificial voltage. It's communicating back and forth, kind of in a DC signal. And you can read that with meters similar to what's on the screen here. This happens to be an analog meter. Typically, that's what they used for many, many years. Back when I first got into business, that's basically all we had. It didn't have too many digital meters back then. But an analog meter is really easy to see this type of signal. You'll see the needle bouncing around as it's receiving the voltage that varies. I just recently bought an analog meter at a big box store. I paid around $10 for it. So they're not real expensive. You can get an expensive one, but it doesn't have to be. And so in our training room, we have some analog meters, a number of these field piece type meters, and a fluke meter. The analog meter is the easiest one to read. Now, let me just click on this and I'll show you the type of signal that you can get. That needle you see bouncing around is a typical type of signal you get between the indoor and the outdoor unit when you're reading down here on S1 and S2. I'm sorry, and S2 and S3. S1 and S2 is line voltage. S2 and S3 is your communicating voltage. Okay, so if I come over here to this field piece meter, field piece is a little slow, so the digital signal that you'll get up here will be you won't get much of a reading up here. You'll get it flashing and blinking and doing things, but you aren't going to see too many voltages. The analog signal on the bottom here will rotate back and forth. You get a pretty decent type of signal similar to what you got up here in this meter. So let's just click on it and I'll show you what I mean. Voltages are bouncing around here. Once in a while, you'll see a number pop up, but not too often. But down here, this analog meter going back and forth is giving you a really decent indication that the unit is communicating back and forth and doing it pretty effectively. If we go over here to the fluke meter is a lot faster, responds a lot quicker. So up here, you will see some voltages, and then there's also an analog meter on the bottom here, which looks a little different than this. So you got to get used to what your particular meter will do. As you can see up here, we are seeing voltages. As you can see, it changes from 9 to 24 to 14 to 16. You know, it just keeps bouncing around. And then the analog meter on the bottom is bouncing around. All three of these indications that we've just seen here are good indications that the system is working properly. I would suggest if you have a meter that's not one of these, to put it on a good system you know is working fine, just to see what you could expect. So if you do have to go out on a piece of equipment that's giving you some problems, maybe that you can see if it's acting correctly or not according to your meter, the way your meter works. So let's get into some of the electrical diagrams. This particular one is a PUZ A42. It's got two outdoor condenser fans. It's a P series. The diagrams that you will download from mylinkdrive.com will be all just black and white. For the sake of this training today, we've got some colors in here that should help you to see it and trace it on the screen a little bit better. But in the books, they're just black and white. L1 and L2 is your line voltage coming into the unit. First thing it hits is this is a noise filter board. This actually has 3 boards. This is an accessory. It's 3 boards. The first one is the noise filter, like we talked about on the first session. That kind of helps clean up the AC voltage. Then it goes over here to the power board. PB standing for power board, NS standing for noise filter. Comes in here, and this is, if you put a voltmeter across here, you'd be reading 208, 230, 240 volts, right around there. Whatever you're seeing down here should be coming through to this board here. You come through these 2 devices here, and it's converting the voltage into DC. So it's kind of like the intelligent power modules. You'll notice right here, the red wires, that's a DC, direct current voltage. It should be around 300 volts DC. Notice right here, the tip of my little pointer there is a plus, and there's a minus here, a plus here, and a minus here. Hopefully you can see that. Those are plus and minus. If you put a meter on there, you'd have a positive and a negative terminal that you'd be looking at. So that's the way that works. Now it comes down here, if you follow these voltages down, comes through to this device here. Now the ACTM stands for active filter module, and this thing up here, this DCL, is the reactor. That's the reactor I talked about that earlier session that looks like a transformer. It looks like a transformer the way it's drawn here. It looks like a transformer if you actually see the device itself. And it actually helps smooth out that voltage circuit. Sometimes this reactor is on the AC circuit side, and sometimes it's on the DC side. But it's doing the same thing. It's basically smoothing out the voltage. And the power going in and the power coming out of that, if you were to measure it, you should not see much, if any, of a voltage drop. Okay, so the voltage comes out of this board and comes in here. Again, there's a positive and a negative terminal going into the IPM, which stands for Intelligent Power Module. That's, again, something that converts from DC to AC. Now, these are inverters. This is intelligent power module. Okay, now we come in here with DC. We come out with 3 AC power lines that would connect a U, V, and W on the MC, which stands for motor compressor. That's the compressor. So we have 3 distinct AC voltages coming out here. The voltage varies and the frequency varies of that. You see a couple little coils here and here. We're monitoring that voltage up here on this board. That's coming through these signals here. Some of these other signals coming in here are monitoring the voltages and seeing what we know, what we're telling the compressor to do, what it's actually doing, and what type of signal it's getting, we're reading there. If it sees something it really doesn't like, then it's going to shut the equipment down or give you an error code or both. So we coming out of here, this is a DC signal, and you see this terminal CNDC. Again, Mitsubishi language, anytime you see CN, that's connector, and this is a connector DC. So we're looking at DC voltage here. This is a pink or a hot pink connector right here. Anytime you see a hot pink connector on Mitsubishi, it's going to be DC voltage, and it's usually labeled CNDC. So that's putting power up to this board. And again, it's coming in the CNDC. You'll notice this little 2 here. This means there's 2 wires in here. And then this is 1 space and 3. That's a 3-pin connector. There's a 3-pin connector here, and we're only using pin number 1 and 3. Nothing's on 2. It's because 300 volts DC can jump. It can arc or spark. So we spread those apart on the connectors so that we don't have any arcing. Then those come up and they feed these MFs or motor fan. That's this fan and this fan on the outdoor unit. Now, you'll notice we're feeding DC voltage to that. But on the fan, I don't know if you can see it, right here, there's a 3 and a squiggly line behind it, 3 and a squiggly line behind it. That's like the sine wave for AC. So they're saying that's a 3-phase fan motor, but we're pushing DC voltage to it. What that means is on top of that motor, if we would actually take the back off the motor, got the shaft out the one end, the back side of the motor, you'd pull it off. If you could do that and look inside, you'd see a little electronic circuit board in there where your DC voltage goes to it. And then coming out of that circuit board, you will see 3 terminals that are labeled U, V, and W that go actually into the windings of those motors. So those are actually a 3-phase type wound motor. And we're feeding it with DC. These other wires coming back are telling the motor what to do and giving us a feedback of what the motor is actually doing. So we can actually tell what the motor is doing. Also on this board, there's a linear expansion valve. There's some thermistors up here. And down here is the reversing valve, because this is a heat pump. It's a PUZ heat pump. If this was not a Z, if it was a PUI, this would not be used. That's why it says for PUZ only. This up here happens to be an MNet board. That's an accessory that could be added. Because it's a P series, we can link all these together on a network system and control them on one big central controller if we wanted to. Not done very often, but just be aware that that is available. This other little wire here, this kind of a yellowish wire, that's the S3, which is a DC signal, pulsating DC signal that you would read between S1 and S2 that we just talked about. And we should be looking at 300 volts DC here and here, coming in and out of that is about 300 volts DC. Up here, this is an MXZ HC48 NA8Z. So what that means is MXZ is a heat pump, X meaning it is a multi-zone heat pump. This can handle up to 8 zones. It is a 4-ton unit, and the HZ in the end means it's a hyperheat. So what we got here is a hyperheat unit. This is the unit that does require a branch box. But you'll see we only have 2 basic boards here. There's a little board here that powers the MNet, but there's 2 basic boards here. So you've got your noise filter and your power board here, all on one board. So we come in here with line voltage, 208, 230 in here, cleans up the voltage somewhat, sends it over here to the IGBT. Again, that's integrated gate bipolar transistor, which changes that voltage over into DC, about 300 volts DC, and you'll see a little plus here and a little minus here, indicating that this comes in with a little sine wave there and a sine wave there. So we're going in here with AC, we're coming out with DC. Again, 300 volts DC. We come down here to the reactor. It's labeled DCL. DCL stands for reactor on some units, and it may be labeled L on others. So just look at the legend that normally is in the system. We'll have one of these things with a legend that I'll show you. Comes out of here, goes through the intelligent power module, which converts it back to 3-phase AC. You see these little coils where they're like amp probes that we're measuring the amps, and it goes into the motor compressor. And we come out of the CNDC with 2 wires up into the CNDC, and similar motors here, thermistors up here. There's LED 1 and 2. That's some readings that I'll talk to you about in a few minutes. And this board here is powering the MNet. Let me click this one more. And we come in here with 208, 230. We come out of here with 29 volts DC that internally comes out here on this board and goes out to this terminal that goes, this is the 16 gauge twisted shielded pair of wires that goes out to the branch box. Also down here, the line voltage comes into the board. It also comes up here and goes to this set of terminal blocks, PB1B, which is to the branch box. Okay, the next is the branch box. This is where the 16 gauge twisted shielded pair comes in and lands on the branch box. Comes down here, that's the MNet. And back from these terminals here, this B1 and B2 comes in right here to this terminal block. So there's your line voltage going in. We do convert to some DC here. We're going in AC, and there's a DC that's not really shown here, but we know this is a DC signal here, and this is a communicating DC signal between S2 and S3. Excuse me. The S, I shouldn't be touching my nose, but I'm the only one here, so I'll wash my hands afterwards. Doing this during the COVID situation, so it's critical that we don't scratch and touch our nose. So knowing I'm not supposed to means I gotta touch my nose. Anyway, right here is where the indoor units get hooked up, the S1, S2, and S3, and ground. And these are LEVs, which are inside the branch box. These are thermistors that are pipe temperature thermistors that we're sending back a signal to. That is where you set your address. Remember, we mentioned it, we normally do it. Mitsubishi suggests that the 01, we would normally do 11 or 12, or 11 or 22 to make it a little bit easier. Because sometimes this branch box is right side up, sometimes upside down, sometimes hanging on the wall, and just putting a 1-1 in there makes it real easy. Okay, so much for that. Again, we got 29 volts here and line voltage here. Okay, this is an MUZ FH, again, an outdoor unit. This happens to be a heat pump. L1 and L2 come in here for line voltage, and S2 and S3 are your DC voltage. It says 12 to 24 volts bouncing around type voltage here. And we've got the noise filter in here. This L61 happens to be that reactor that looks like the transformer. Again, this time it's on the AC side. It comes in here to this device that converts it from AC to DC. Again, you see the little AC sine waves there, and a minus and a plus here. This comes out, and some of the voltage goes over here to the intelligent power module that converts it back to 3-phase AC, and some of it comes over here, and we are feeding U, V, and W directly here with 3 wires to this fan, this outside condenser fan motor. We also have a linear expansion valve. By the way, anytime you see that little crooked symbol right there, that's a DC signal. That little signal there is a sine wave for AC. This would be a DC signal. Sometimes we see the DC signal that looks like a line and then a bunch of dots under it. Either one of those would indicate DC. Moving on here, again, same kind of voltages we're looking at. You're talking to the varying 12 to 24 volts DC here. We're talking 208, 230 volts here, and we're talking 300 volts coming out here DC. This happens to be an MSZ-FH. This is this ceiling or this wall unit. And this wall unit has 2 separate horizontal vanes. And we also have some vertical vanes in here. And then this has got the IC sensor down here, which rotates back and forth. So what we're looking at here is we're coming in with S1 and S2 with line voltage coming into the unit, and we're communicating between S2 and S3. You'll notice we come in here to this power module where we have AC volts coming in and DC volts coming out, and we're going to the fan motor with DC voltage, 5 wires going in, but it is 3-phase. So this fan motor has got the little board inside that's going to convert it back to AC. Coming down here, we've got this little mark here, which means DC. We got 1, 2, 3, 4 DC MV1s. Go over here And we see MV1 is a vane motor horizontal, that's for these. And then we have a vane motor vertical here. MV2, also a DC voltage, and it's got 5 wires going to each one of these. Coming in here off of the CN151. Then we have another motor right down here, which is DC. That MT is this motor on the, does it have it on here? Right here, IC sensor motor, that's right here. So that's driving the IC sensor back and forth, rotating it, trying to see what's going on in the room. RTs, which are thermistors. Does it tell me that on here? RT11 is room temperature thermistor, coil temperature, coil temperature. And one's entering, one's leaving the coil temperature, main and sub. So that's kind of very similar the way we operate. Now let's look at the refrigerant system overview. This is how the refrigerant systems work. As you know, the first session we covered some of that as well. I believe it was the first session, maybe it was the second session. But this particular is the MXZ8C. This is the 4-ton unit with the branch box. So this little dotted line here, that indicates the branch box. So this is inside. All this over here is inside. This is all from these service valves is outside. We have the compressor here. And like we talked about earlier on, we've got a suction line, a discharge line, and this other line coming in, adding a little saturated vapor back into the compressor if needed. We come out of here, we have, you know, this is a thermistor, we got a high pressure plug, high pressure switch, oil separator. We come back through the reversing valve. In this case, the liquid is outside. So we're in the air conditioning mode. We're going in here with a saturated liquid. We're coming out here with a liquid vapor mixture and going through a distributor. There's a thermistor here, a thermistor here. There's another heat sink thermistor here. We've got a strainer and a linear expansion valve, a strainer. We're going through that subcooling coil through a strainer, another thermistor, and this is the reversing or the stop valve or the service port valve on the outdoor unit. We go into the branch box. It's split up in the branch box. In this case, we've only got two. We've got a 5-head branch box. These are 5 LEVs, is what's pictured here. These are cap tubes. And then we go out to the indoor coil. We got an entering coil temperature thermistor. We've got a room return air temperature thermistor, and we have a leaving coil temperature thermistor that's actually in the branch box, coming back in through the service port, ball valve through a strainer. We're looking at another thermistor. Go through this hybrid accumulator into the suction port, and then of course through here we're taking some gas and we're changing the temperature state and feeding some refrigerant back into the compressor to keep the compressor cool and to get as much heat as we can out of the system. This is a PUZ-HA. HA would indicate that it's also a hyperheat. So there's a 3-ton P series. Very, very similar. Here's a compressor. We come out of the compressor. There's a thermistor, a muffler. We come through the reversing valve to the outdoor unit. You've got a outdoor entering pipe thermistor, heat exchanger thermistor, an outdoor temperature thermistor, and there's the outdoor pipe temperature thermistor and a leaving pipe temperature thermistor. Through a strainer, linear expansion valve, again through the heat exchanger, up through this hybrid power receiver, strainer, linear expansion valve, another strainer, and into the indoor equipment, back in from the indoor equipment, through this power receiver, through another strainer, another thermistor here, and back to the compressor. Works very similar to the other one. The only thing is, it looks pretty simple on here. When you open up one of these pieces of equipment, you actually see inside, everything's pretty tightly done. So just be aware that it's you want to have good installation techniques so you're not plugging up any of these strainers or cap tubes or anything. Okay, this is an MUZFH. This one does not have, this is a hyperheat, but it does not have that third pipe. Don't need it on this unit. We come out of the compressor. We have a discharge temperature thermistor, a muffler, service port in there through the reversing valve to the outdoor coil. We have a entering and leaving thermistor. In this case, we may call it a defrost thermistor, and an ambient air, outdoor ambient air thermistor. We have some cap tubes, kind of the distributor combination cap tubes that get rid of some pulsation, keep the pressures up. We go through another strainer, another linear expansion valve, another cap tube, and then we go through the valve to the indoor equipment and then back through a muffler, a reversing valve, service port, suction line accumulator, and back to the compressor. This is relatively simple, but I wanted to show you how we have all these cap tubes here, and all these strainers. So the strainer can plug up, the cap tubes can plug up, the LEVs can plug up. So again, really good installation practices mean a great deal on this. Let's get into a little troubleshooting. Fault codes, we'll talk about fault codes and so forth. Test point diagrams. Indoor unit fault codes. Now, just be aware when you download the equipment, you're looking at whether it be an MU something or a PU something, that'd be an outdoor unit, or MX, maybe an outdoor unit, but just make sure that you have the correct indoor and outdoor units. Sometimes you can have an SUZ or an SVZ. Sounds very similar, SVZ 36, SUZ 36. One's an indoor, one's an outdoor unit. Make sure that when you download the service information, you know what unit you're looking at, because on the indoor head, it may have a flash code. Right down where the receiver is, there's some lights we talked about earlier, and that light will flash a code. In this case, it says 2-time flash, 2.5 seconds off, and then flash twice, and 2.5 seconds off, and flash twice. That's a 2 flash. That means you've got an indoor coil thermistor bad on this particular unit we're looking at, which is an indoor unit. Now, if I switch over here to the outdoor unit, you can look at a 2 flash on the outdoor unit, and that's saying you got an overcurrent protection. That's the looks like amp probe, those coils that are looking at the compressor. That's what this thing is looking at. It's saying it doesn't like, the inverter doesn't like what it's putting out, so it's going to shut down or give you a 2 flash code. Make sure you're on the right book, because these codes change from unit to unit, and between the indoor outdoor unit they change. Okay, outdoor fault codes. You've got symptoms here, and it gives you the abnormal point. Outdoor thermistors tells you the condition that might be happening and maybe the remedy, what to do. Replace the inverter PC board, for instance, in this case. And these were all 1-time flash every 2.5 seconds. Could give you any of these 3 things to look at. So make sure you look at the service manual for the complete fault codes for the specific piece of equipment you have. This information I'm showing you here is for one particular piece of equipment. It varies. Also, remember I said that some of the boards and some of the units sit on top and are upside down. Here's an example of an upside down board. This is the underneath side of the board. We have a test point diagram here that if you open it up, this diagram will look exactly like this unit sitting upside down. So it'll tell you right here, you should be looking at 5 volts DC or 12 volts DC. So if you don't have to lay on your back and try to take these readings. You can take them right off the back side of the compressor. It's telling you there's a ground terminal here and tells you where to look for the voltages. See, this is a ground terminal here. And between here and this terminal, you should look at 5 volts DC. Between here and here, you should be looking at 12 volts DC. You know, there's your vane motor. So you'd have to look at the vane motor section to tell you how to test, but you can test it right from the back side here. Isolating faulty components. The discharge temperature thermistors. This one is for an RT62. They are different. This is not the same chart for every single thermistor, so you'd have to look in the book to verify. But in this case, if you were getting a signal that said you got a bad thermistor, you're getting a flash code. If you're looking at the flash code, it may give you a bad thermistor and that's it. You've got a bad thermistor and there's 4 thermistors on the unit. Now you'd have to pull each one off the board and ohm it out. And if it was, for instance, this is Fahrenheit. So let's just say it was, let's look at something simple. 50 degrees outside and you're reading 400K ohms. You'd say there's nothing wrong with that thermistor, it's fine. My personal experience is a lot of times the thermistors are open or they're shorted. Usually they're open because some little critter was in there gnawing on the wire. Thermistor wires are very small and they're easy to chew through for something like a mouse. So I do see open thermistors all the time. So I usually just put my meter on there and see if it's opened or shorted. If it's opened or shorted, it's definitely bad. If I'm getting a reading, then I go to the book and see if it's an accurate reading. Usually if I'm getting a reading, it's good. It's usually open is what I see. Down here, this is a linear expansion valve, and it's telling you how to check it out. A linear expansion valve is nothing but it looks like a big coil on top. It's actually a series of 4 different coils in there, with red being your common. So you're going to take a resistance between white and red, should be here, red and orange, yellow and red and blue. Should be getting a reading like this. It's like a motor winding. It spins the linear expansion valve up, and spins the pin down to like 2,000 in some positions. And that's the way they do it. So you can actually check the resistance and see if it's open or closed. I've seen where that's actually popped off in shipping and we're getting some weird, it's not cooling properly or heating properly. You go in there and you find that that it's popped off of its port. It just literally has a little clip that pushes it down into place. Now they've been taking a wire tie to it and tightening down so they really can't pop off, but that's just something to check if you're getting some erratic readings. And then the high pressure switch. Remember we talked about leak testing and we said check to 600 pounds. Well, you'll see that this high pressure switch opens at 696 pounds. So we've got no problems. You got another almost 100 pounds in there before that thing will blow when you're checking for leaks. Now here on the outdoor unit, remember I mentioned these LEDs a few minutes ago? This is the outdoor board. This is what you'll see when you look at the service facts. You'll see the linear expansion valves here. These are thermistors up here, the fan motors, just like the boards we just looked at. Right here, there's LEDs. There's 2 of them together and they kind of look like this right here. And you open up the cover, and I've had this happen several times where somebody will open up the cover and say, hey, I've got a fault code on the outdoor unit. It's 1111. That is not a fault code. This particular display, we use it in like 3 different manners. In this case, these are called flags or segments. Mitsubishi calls these flags. And there's a 1, 2, this is a flag 3, this is a flag 4, 5, 6, 7, and 8. So there's 8 different flags across here. Right now they're telling you that number 8 is on, flag on, which says it should always be lit. Basically means there's power to the unit. These other three mean, the first one means that the compressor is operating. The second one means 52C is working. So that means that the relay drive signal that drives the compressor is made. And the fourth one is service valve 1, or bypass solenoid valve. It's a solenoid valve 1. So it means that it is in, I believe that's when it's made, it's in the cooling mode. Okay, so that's one way these things work. Now, there's another way. It can actually read a fault code. So it'll give you something like this, 5108. That's a true fault code. And it would be blinking like this, going back and forth, 5108, 51, 5108, 51, or maybe 5108, 55, 5108, 55. What that is the address of where are we? That's the address of where the fault is coming from. Mitsubishi tells us to address 51, or address the outdoor unit as 51. I told you 55. As long as you know that the unit was addressed, we don't have those on here. They're not showing on here, but if this was addressed as 51, it's telling you that that 5108 is coming from this outdoor unit. It might say 5108-22, and that might be an indoor unit. So it kind of gives us an indication of where the fault is coming from. So now if we look here at fault codes, this is the fault code reading for that unit. This is one of the pages. You'll notice there's check codes, and it has these codes here, this like U2 and U4 and so forth. So a U4, where that would show up would be on the controller itself. Looks like a thermostat, what we call a controller. On the controller, it may be flashing U4, U4. Okay, U4, if you look over here, there's 1, 2, 3, 4, 5 different things that could be U4. They're all thermistors. They're a thermistor, pipe thermistors, outdoor thermistors, ambient thermistors, just different thermistors. So it would tell you that you got to check your thermistors, which are right up here on the board, the thermistors. Remember, we had a 5105. So if we go a little bit further to 5105, it's U4, which is the thermistor, and it's telling you your outdoor pipe thermistor, temperature thermistor, your liquid pipe temperature thermistor, TH3 is open or shorted. If we go back here, these are your thermistors. TH3, which is a white connector, there's a problem with. So I would pull that out, take your own meter in there and see if it's opened or shorted. If it is, replace the thermistor or find where the wire is bad and try to repair it, at least temporarily. I would always replace it, because just twisting wires together with a wire nut is probably not the best. But I would try to, you might get them by for a few days, but order the right thermistor. Okay, that's one thing you can do. Now, let's go back here. Right here, this TSW1, these are switches, okay? So we can change this dip switch, SW1, looks like this, 0 meaning off, 1 meaning on. If we go down here to this page and we turn them on and off, we can see the pulse of the various LEVs. You can see the liquid temperatures on these thermistors. You can see the LEV pulse rates down here. And in this case, we're going to go over here and look at number 78 is TH3. Remember, that's what we said we had a problem with back here. This 5105 said it was TH3 was open or shorted. If we would go here to that switch and switch 0 is off, so we switch number 2, 3, and 4 to the on position, and we take the second from last one, number 7, and switch that on. This display here will now change and give you a reading. And if the thermistor was good, it would actually tell you the temperature the thermistor was seeing at. If it's bad, it's going to read either negative 99.9 or 999.9. So that's either shorted or opened if it reads one of those two. If it actually reads a temperature in there, it could tell you it's 75. If it's outside air and it's 75 degrees and the unit's not running, that would be okay. So it's kind of neat. You can use that. You also have the error code breakdown, which will steer you in the right direction. You might get on one of these back here, it may say check. Let's go back. It might tell you to check your code, the CN31, connector 31 is bad. Let's see if I've got that here. I don't know if I do. I'm not seeing it here, but that doesn't mean I don't have it. No, I don't see it. But if you had a bad, if it told you to look at connector 31, you go to these diagrams and it says, check the sensor. Is it plugged in? Does it look tight? Yes. Then you go down here. Is the resistance of the thermistor normal? Yes or no? You have to go to the, you look at the drain pan sensor rating and see if it was open or closed or shorted, and it would tell you if it was good or bad. In the instructions, occasionally there are primary codes which are LCD displayed on the remote controller, the thermostat. The faults appear as a letter number combination I mentioned. Secondary, it would tell you it's an inferior phenomenon. Those are indicators that are displayed in some other manner other than a fault code. It may not be a flashing light. It may not be the alphanumerical 2-letter code on the remote controller. An inferior phenomenon or something that it's not picking up on. That's where you as a serviceman would have to look at the system and say, you know what? I hear something funny. That fan blade's hitting some ice outside and it's ticking. I wonder if that's it. Let's knock the ice off and see if that doesn't solve it. Maybe you open the system up and find a rat's nest in there and smell something burnt. Well, if it burnt up, if the outdoor board burnt up, obviously you're not going to get any code on the controller. It's just going to be blank. So you have to look for something, smell something, hear something. It's kind of your senses. That's the inferior phenomenon they're talking about. It's something that you're going to have to see for yourself. You'll probably spot it. There's the 2-digit codes we're talking about, maybe a P5 or P4 area codes that show up on the P series units. Occasionally these codes will show up on a MHK1, that's that Honeywell type thermostat, on an M series, but they won't typically be in the M series book. You have to go by the LEDs, blinking LEDs, to determine what's wrong on the M series. The P series sometimes will give you a 2-digit code like this. So it's kind of telling you where you might look, like drain flow over protection, and it'll tell you what may cause it, what a possible solution is, how to fix it. On the P series, you also have a red, what's called LED 1 and a red LED 2. There's a green and red light. If the green light, you might say, is blinking 4 times and the red one is blinking 1 time, that might mean that you've got a bad thermistor. If you had the controller hooked to it, the controller is probably going to give you a P1 fault code, and it's going to tell you to look at these connectors on board. So we kind of steer you to the right connection. Now here's one of the controllers we talked about. It comes right up on the control and tells you error code E4. So hopefully maybe your homeowner or the business owner would call you and say, hey, my unit's not working and the thermostat says there's an error code E4. Error unit IU. Anybody get an idea what that means? It's indoor unit. Could say outdoor unit or it could be an indoor unit, but this would be the indoor unit is throwing a fault code E4. We'd have to go back, find out what an E4 is and correct it. You're also going to get a blinking light down here. And if you've programmed the information in, it would give your telephone number for you to call. You can't, in this case, you can't put your name in there, but it will give a telephone number who to call and it'll be your shop. Troubleshooting resources, as always, all of this stuff we talked about today is in MyLink Drive. This is a tablet. It works well on a phone, on a computer. Does not work real well necessarily on Apple, but it does work on all PC related devices, and it will work on smartphones. Actually, it does work on Apple. Anything that will, you can't download this to an Apple device, but you can access it on the web, the internet. As long as you have internet access, you can get to www.mylinkdrive.com. If you really wanted to, down here, it's saying that you can download this PC link to your PC. Won't work on a cell phone, won't work on an Apple, but if you had a laptop, you could literally download this whole MyLink Drive, which is thousands and thousands of PDFs. If you're going to do that, do it at night, go to bed, and hopefully it'll be done downloading in the morning, and hopefully you have enough room to put it all. But you could do that so that if you're out in the country where you maybe don't have a signal, you can always get these documents. Okay, tech tips up here. Oops, I didn't want to do that. I'm sorry. Let me go back. Tech tips here. If we would click on this, this would take me to MyLink Drive. We do a live demonstration. But if we click on tech tips, we get to a whole bunch of tech tips. And one of the tech tips I wanted to show you is this video on removing the blower wheel. And this really helps on cleaning the system, because occasionally the blower wheel will get that organic growth or just a lot of dirt and crud on it, and you need to take it out and clean it. So there's a little 2-minute video I want to show you here, and we'll take a look at it right now. Let me bounce forward just a little bit here. There, and over here. It's tabs right here, here, and right behind his shoulder here. And this would be full of water possibly. Right up in here. That bearing can fall off, so don't lose that. Okay, so hopefully that helped you out a little bit. Now I'm going to tell you a couple of things. He said use water. we do sell some products that are specifically designed for mini splits. The video here that I'll just bounce through a little bit to give you an idea, but there's some aerosols. There's this bag, which is kind of nice for maintenance. And then there's some other products that we probably won't cover, but we handle all of these. Let me bounce along here. Oops. We don't say mold. You see all this water is going into the pan and into the bag. That's it. I just wanted to show you how to clean the system a little bit. I wanted to, the last thing here is this is how to get a hold of us service advisors. You see all of us are on here. You can copy this down or get a copy of this at the store, or we can email it to you. But that's me on here on the top. Do application support. I also do technical service advice on here. You can call any of us directly on this phone here. Matt's on the bottom. He's our newest guy. He's out of Des Moines. All these other guys are from other parts of the country. Now, Sean and Dan here at the bottom are primarily City Multi. They work for a subsidiary of us called APS, and they deal exclusively with City Multi, the large commercial, you know, the up to 30-ton type equipment we talked about first session. But otherwise, all of us on here, everybody on here is adept at answering these questions. You can call or email customer service at Mitsubishi, or call this 800 number and get directly to Mitsubishi, or you can call this 800-827-9508. When it answers, hit option 2, and that'll go directly to our service advisor hotline, and that support line will show up on every one of our phones. And so if you try calling me and I'm on the phone, you may have to wait until I get off the phone. Some of our calls are short 5-minute calls. Some of them can take quite a while. If you leave a message on this service advisor line, one of these guys will probably not be on the phone and will call you back, usually in 5 to 10 minutes. It's pretty quick, because as soon as somebody finishes up, they'll pick up that call and give you a call back. David and I work together in Plymouth. David picks up a lot of calls off of that hotline, I know, but all the other guys have access to it and will answer the calls readily. If David's out doing training, or if I'm out doing training, the best thing to do is call that line, and you know, Larry or Steve or somebody else will pick up the call and handle it. We do a very, very good job. When you call Mitsubishi's technical support line, you're going to get a tier 1 technician who's going to ask you model number, serial number, all this. And then when you ask the actual question, they may say, ooh, that's a little tough. I'm going to send you up to a tier 2 or a tier 3 technician. All of our guys are tier 3 technicians. So you probably are doing better to calling us first and not waiting in line for Mitsubishi. We have more service. We have as many service people as Mitsubishi does, I think. So we should be able to answer your questions pretty quick and very accurately. Like I said, we've been handling this product back since 1983. So not to pat myself on the back, but we're pretty good at support for this product. And I like to say better than anybody else in the country, but there's some very, very good distributors around the country. So if you have any questions at all, give one of us a call. We'd love to help you out. And if you have any questions, you can just call into that line, ask the questions, and we'd be happy to send you the information. And aside from that, I really appreciate you putting up with me for all these hours. And thank you very much. And you have a terrific day, and stay safe out there.